In October 2017, astronomers using the Pan-STARRS 1 telescope in Hawaii detected an unusual object moving through the inner solar system. This object was later designated 1I Oumuamua, with the prefix 1I denoting that it was the first confirmed interstellar object, and the Hawaiian name Oumuamua translating roughly as a messenger from afar arriving first. Pretty apt description. Oumuamua's orbit was hyperbolic, meaning it was not bound to the sun. It was passing through and would leave the solar system permanently. Brightness fluctuated dramatically as it rotated, suggesting an elongated shape, perhaps 10 times longer than it was wide. Imagine a tumbling cosmic rod, reflecting sunlight in sudden bursts. Yet it exhibited no visible coma, no gas or dust tail typical of comets. Despite this, it experienced a small, non gravitational acceleration, deviating slightly from the path predicted by gravity alone. This could be caused by a phenomenon known as outgassing, which we have detected in comets. Several theories that attempt to explain Oumuamua include one that proposes that it is a comet like object ejected from another star system, the most likely outcome, potentially from the direction of Vega in the constellation of Lyra. The journal Astronomy and Astrophysics noted that binary star systems are extremely efficient at ejecting material, making Oumuamua like objects plausible outcomes. Another hypothesis suggests that Oumuamua could have been a hydrogen iceberg. Composed primarily of frozen molecular hydrogen, in this scenario, sublimation near the Sun could provide thrust without producing a visible tail. The journal Science Focus explains that the sublimation of molecular hydrogen could produce a small thrust without the visible coma. The most controversial idea is that Oumuamua might be an artificial object. Researcher Avi Loeb stated, encountering an object like Oumuamua is not unthinkable. We ourselves send objects outwards, so why wouldn't other intelligences? However, most researchers remain skeptical, believing the artificial solar sail explanation is improbable, given the likely travel time and energy requirements needed to launch such a probe. A feasibility study of a mission to interstellar objects, dubbed Project Lyra, explored ideas on how to catch up to such fast moving targets. Ideas included using advanced propulsions such as solar oberth maneuvers, laser sails, and nuclear rockets. While Oumuamua itself is unreachable, these studies established a foundation for future exploration. Imagine a spacecraft chasing an object from another star, attempting to study it up close. This is the boundary where science fiction meets science ambition. Yet, not all interstellar objects are so mysterious. 2 years later, another visitor arrived, behaving far more like the comets we are familiar with. In August 2019, a second interstellar object was discovered by amateur astronomer Gennady Borisov. Designated 2I Borisov, this object differed from Oumuamua in several ways. Borisov resembled a classic comet, with a coma, tail, and outgassing as it approached the Sun, yet spectrographic analysis revealed an unusually high proportion of carbon monoxide ice relative to water ice, far exceeding levels seen in the solar system comets. This indicates formation in an extremely cold environment, likely around a red dwarf star. NASA summarized it simply as, this comet is the first sample from another star that we can directly measure. What's going on when planets form around another star? Even the dust in the coma was distinctive. Compact millimeter sized grains suggest a complex history of formation and ejection. The journal Science Daily reported the dust grains had experienced compaction in their home protoplanetary disk. Unlike Oumuamua, Borisov's behavior aligns closely with the conventional cometary physics. There's no compelling reason to invoke artificial origins. Mission concepts considered intercepting Borisov, but its high speed and late detection made a rendezvous technically unfeasible. Nevertheless, each new discovery prepares us for future opportunities. Then, a third interstellar visitor arrived. One that combined some of the strangeness of Oumuamua with the cometary familiarity of Borisov. In July 2025, astronomers identified 3I Atlas, the third confirmed interstellar object. Atlas is larger than its predecessors, with a diameter of several kilometers, and displays unusual chemistry. Its retrograde trajectory suggests it may have originated from the galactic thick disk, a population of older stars distinct from the Sun's neighborhood. Its size, composition, and trajectory imply that it could be billions of years old, a relic of ancient planetary systems. As the paper El Pazi described it, Atlas is neither a spaceship nor alien in origin, but rather a fragment from another star system. Even so, Avi Loeb suggested that, quote, Atlas's unusual trajectory and size make it worth considering a 30 to 40% chance of artificial origin, though natural explanations remain more likely. Detection capabilities are improving. The Varese Rubin Observatory will survey the southern sky every few nights, potentially detecting dozens of interstellar objects each year. And the European Space Agency's Comet Interceptor, which is scheduled to launch in 2029, will station at the Sun Earth L2 Lagrange point to await interstellar objects to study them up close. Examining Oumuamua, Borisov, and Atlas together, a pattern emerges. Oumuamua challenged all expectations: unusual shape, unexplained acceleration, no visible analog in the solar system. Borisov was familiar in form, yet distinct in composition and clearly extrasolar. And Atlas brings scale, chemical anomalies, and the possibility of ancient origins. As Johns Hopkins University Applied Physics Lab noted, each object adds a piece to the puzzle of interstellar material and planetary formation beyond our solar system. With the advanced surveys, the Comet Interceptor, and possible Project Lyra, we are transitioning from observation to deliberate exploration, moving closer to actively studying visitors from other stars. The solar system is not isolated, and interstellar objects remind us that we exist in a galactic ecosystem where material travels between stars, carrying history of distant worlds. Each of these objects, Oumuamua, Borisov, Atlas, is a messenger, passing briefly through our view, offering a fragment of the galaxy's story. And now, for the first time, we're preparing to read it.